Merve Alanyali from University of Warwick. I'm a third-year PhD student at Data Science Lab in Warwick Business School and an enrichment year student here at the Turing Institute. And today I'll be talking about my PhD, which is quantifying human behaviour using online images. So measuring how people behave is of vital importance for social scientists and policymakers to inform scientific theories and decisions about interventions. So traditionally, especially policymakers, used to gather this information via surveys. So these surveys provide useful and rich insight into human behaviour, although they have certain drawbacks. For example, the speed at which you can collect and gather the data and the resources at which you can collect this data, and how willing or actually able the people are to report on their everyday behaviour. And as you all know, we leave vast amount of data behind through our everyday interactions with the technological devices and the online services they're connecting us to. So this data tend to gather information about our everyday behaviour, and it's available globally at low cost and high speed. So the potential of capturing everyday behaviour of human beings at high speed and low cost, and improving predictions about human behaviour by identifying repeating behavioural patterns, has led to a new interdisciplinary science which is called computational social science or social data science. So it yields to a wide range of interesting questions, and at the same time it acts as a complement to traditional survey-based methods. So if you've been to the talks by Tobias Price or Susie Moge, who are my supervisors again at Warwick Business School, they gave various examples of using this online data to measure human behaviour, like ranging from Google data to Wikipedia data. But with the improved connectivity, online information has been shifted from being only text-based to visual media, such as images and videos. So this data usually has information on where they were taken, especially if it's taken with a smartphone. This information is mainly embedded in it. So in my PhD, I am trying to measure human behaviour by analysing images that people share online. So obviously this is a really wide topic, and I have 3 subtopics under this wide topic, and one of them is detecting events. And today I'll be talking about one of the projects I've been working on under that subtopic. So recent years have witnessed waves of protests sweeping across the countries and continents, sometimes resulting in a political change, or emerging as a result of a political change like nowadays. So during the time of protests, people use social media not only to share cute puppy pictures, but also to mobilise the public, organise protests and spread information, which is really vital, especially in the absence of a reliable information source. So therefore, much media attention has been focused on the increased usage of social media channels, especially during the time of protests. So I investigate whether I can track and identify protests around the world by analysing online images shared on a photo sharing website, Flickr. So I analysed pictures taken and uploaded to Flickr in 2013 across 244 countries and regions. And these pictures are nearly 25 million, and they are geotagged, which means that we know where they were taken and also where they were uploaded. So for each picture, that was the data that I was interested in, where and when it was taken, and the text data attached to the picture, which can be either the picture title, or the tag, or the description. So for each picture, I identified whether the word protest is somewhere in the picture text. So luckily, Flickr has a really good API, so I managed to download the data, although it looks a bit like that, but it's in JSON format, so you can easily work with this data. So for every week, and each one of these 244 countries and regions, I calculated how many pictures have the word protest in it. And then I repeated the same analysis for 33 other languages. But obviously, different countries post different numbers of pictures around the world, and there's different number of users of Flickr. And to account for this difference, I normalised this Flickr tagged pictures by the total number of pictures taken and uploaded in that given week and region. So if I plot this information in a monthly granularity, this is what we get. So there's some pattern going on, but we obviously can't say anything. And to be able to tell if this actually matches with the number of protests that was happening around the world, we need information on when and where the protests have occurred. And unfortunately, such ground truth data is quite hard to get hold on to. And like the previous social unrest studies, we also relied on the newspaper data. So we used the Guardian data, and luckily they have a really nice online tool which is called the Open Platform, which is freely available. You can easily go and search through the articles, download data. So we extracted a number of protest-related news that are covered from that certain country for each week, like we did for the Flickr pictures. And again, we normalise this number. So if we plot it on a monthly granularity, again, so this is what we get. So from visual inspection, although there are big differences between these two data sets, there are some key similarities, which is probably easier to see in this plot. For example, in June, there's an increase in Turkey and Brazil, where actually there were major protests both in Turkey and Brazil in June 2013. To find the statistical evidence that if this is true, I mean, obviously we can say it visually, but we need to do something. We built a logistic regression panel model using countries and regions and weeks as fixed effects to account for unobserved differences. And what we found was higher proportions of the protest tagged Flickr pictures correspond to greater proportion of protest-related articles in The Guardian. And to give some numbers, the odds ratio corresponding to an increase of 0.1 in the normalised number of Flickr pictures, protest-tagged Flickr pictures, is 1.34, which means that if we keep country and region and weeks fixed, and if we increase the normalised number of Flickr pictures by 10%, it would lead to an increase in 34% in the proportion of the protest-related Guardian news. All good. If you want to know more about it, you can go and read, and I'm happy to discuss. But there's some issues with just analysing text. One, not every picture is uploaded with a text attached to it. People can just take a picture and upload it without any tags, title or description. And two, it is language specific. In this study we focused on 34 languages, but you can't always do that. So we thought, why not we analyse the images themselves, the image content. And then I analysed the images. And I used convolutional neural networks for that. And before going into details, I just want to say a few words about convolutional neural networks. So before deep learning, extracting significant features or finding a good representation of an image as a means of feature vector, which then needs to be fed to a subsystem, mainly a classifier, to classify and detect an object, needed a good engineering and considerable domain expertise. So I plotted some features for you, for the image on the left. On the right from top, it's histogram of oriented gradients, and then surf features used for, again, object detection, and then Harris, mainly used for corner detection. I'm not sure if you can see the green pluses at the bottom picture, but anyway. So convolutional neural networks, as the rest of deep learning, is a type of representation learning, which is a set of methods that allows a machine to be fed with raw data and automatically discover the representations needed for detection or classification. Another advantage of convolutional neural networks is it exploits the advantage of natural signals having a hierarchy in it. So, for example, if we talk about images, edges form motifs, motifs form part of objects, and part of objects form objects. And they have all sorts of other really good features like local connectivity, shared weights, pooling, and using of many layers, but I'm not going to go into that. And if you are interested, I would strongly recommend this review paper on Nature, which is quite simple, not that technical at all. And usually these networks are trained on really large image sets. So, for example, some research groups around the world are gathering these image sets, and they make it freely available online, such as ImageNet by Princeton and Places database by MIT. So what you can do, one, you can train your own convolutional net by using a big image data set. Two, you can take a pre-trained neural net and fine-tune it to customize it to your needs, or you can use convolutional net as a feature extractor, not directly as a classifier. So this is what I did. So I created two training sets, obviously, which is vital for supervised learning, positive and negative training sets, and then I used convolutional neural net, the pre-trained one, which I got from Oxford Visual Geometry Group, and then I ended up with positive and negative feature sets, which I then fed into a linear SVM. And that's how I trained the classifier. Okay, positive and negative training sets. What I used for that? Unfortunately, there's no annotated data for protests which I could have used, and I can't go and annotate millions of images or thousands of images by myself, so I cheated. I used annotated natural images from Bing Image Search. So I created an automated search using a search query with the name of the country followed by the word protest. And I downloaded the top 150 images that is returned. And then I downloaded random images that is not related to protest, again from Bing. I'm talking about this part. But there might be some irrelevant images returned, and I thought I should somehow control for it. And then I remembered, the first study I did was about tag analysis, and the results suggested that we can actually use Flickr image tags as a good indicator of protest, so why not I use protest tagged images from the year before. So I downloaded protest tagged images from 2012 and a random set of images, and then perform the steps that I showed you here and train the first classifier. Then I ran this classifier over the set of positive training set that I downloaded from Bing, and only kept the ones that are classified as protest related and discarded the others. And then trained another classifier, which is the final classifier I used. And I obviously tested the performance on a test set, and it performs with a precision of 82.5% and nearly 0.9 area under the curve, so it's plausible. And then I ran this classifier over the set of pictures that are taken and uploaded in 2013 again. So I just want to show you some sample images. So these are the images classified as protest related. And I just want to point out something. It managed to capture different protest scenes with protest signs in different languages, which is what I wanted. And these are some sample images that are not classified as protest related. And the good thing about it is, especially at the bottom right, there's like a big crowd of people. So it is not detecting crowds. It can differentiate between different types of crowds. So I again repeated the same analysis that I did as the text analysis, built a logistic regression panel model, again used the online version of the Guardian articles as proxy for ground truth. And what I found was a greater normalized number of Flickr photographs classified as protest related corresponds to a greater proportion of the Guardian articles being tagged with the word protest. So what do we have? One, we have a baseline model just with the fixed effects, country and region and weeks. One, we had a model with data from text analysis. Two, we have data from image analysis. And I created a fourth model, which I combined results from both text and image analysis. And then I compared these four models by using AIC weights, which basically gives you a probability which model is the best among the models that you provide. And it turned out that the model with information from both image and text analysis performs the best. So these results suggest that online images on Flickr may contain signs of protest outbreaks. And these results highlight the potential of online images as a source of human behaviour, which is rapidly available at low cost and captures human behaviour around the world. So thanks for listening. If you have any questions, I'm happy to answer. If there are any online questions, I'm happy to answer on Twitter.